Example number 43, solve the logarithmic equation 16 log x to base 2 plus 4 log x to base 4 plus 2 log x to base 16 equals to 37. So remember, what did we say? You must have the same base for you to solve a problem involving logarithms. Are we together? So if you look at log x to base 2, 2, 4 and 16 can be expressed in terms of as multiples of 2, isn't it? So remember, when you have log x to base 2, that is the same as log x over log 2, because we've said the base is the logarithm in the numerator. Are you seeing that? Here, when you have log x to base 4, that is the same as log x over log 4. Are you seeing we are now using those laws of logarithms? But now we want everything to have log 2 in the denominator. Are you seeing? So this 4 can be factorized as 2 squared, isn't it? And what did we say? This means it is log x. The power is written as the coefficient. So it is log x over 2 log 2. What is that? That is a half log x over log 2. Are we together? And what is log x over log 2? That is a half log x to base 2. This one just remain log x to base 2. So we've made log x to base 4 to be have the same base. So base 2, meaning you must have the same base to solve a problem involving logarithms. So you see what I'm doing using those laws of logarithms. Then the next one, you have log x to base 16. So log x to base 16 means log x over log 16. The base is the logarithm in the numerator, isn't it? What is 16? 16 is the same as 2 raised to power 4. So the power is written as the coefficient of the log, isn't it? So here it means we have 1 over 4 log x over log 2. So it means we have 1 over 4 log x to base. Are you seeing that? So it means we now have the same base, base 2, base 2, base 2. We've transformed this to base 2, it's already in base 2. We've transformed this to base 2, we've transformed this to base 2. Meaning you must have the same base to solve a logarithmic equation. Are you seeing that? You must have the same base to solve equation. So what do we have? With that explanation, it means here we have 16 log x to base 2 plus 4 into, what is log x to base 4? Log x to base 4 we found is a half log x to base 2, isn't it? Then we have here plus 2. Then you substitute the value we've substituted. This is this, isn't it? Then you substitute log x to base 16. We found is a quarter log base 2 is equals to 37. That 37 must also have base 2. So are you seeing? Every term must have log 2 base 2. Meaning this is log 2 base 2, this is log 2 base 2, this is log 2 base 2. Meaning there, you introduce log 2 to base 2. Why? Because we say a log of a number to the same base is 1. Because log 2 to base 2 is log 2 over log 2. Which you get? 1. So you can now solve this logarithmic equation. Meaning you now have the same base, base 2, base 2, base 2, base 2. You have log 2 base 2 in all the terms, meaning it is now solvable. Are you getting what we are saying? Yes. You have to know all those laws of logarithms. It's when you'll be able to solve a problem involving logarithms. So what do we have here? We have 16 log x to base 2 plus 4 times a half, you get 2, isn't it? 2 log x to base 2. 2 times a quarter, you get a half, isn't it? Log x to base 2 is equals to 37 log 2 to base 2, isn't it? After that, what is the next step? The next step, you get rid of the coefficient, isn't it? Meaning this 16 is the power, isn't it? Are we together? Yes. 16 is the power, so it means we have log x raised to power 16 to base 2. Then plus, this 2 is the power of the number inside the log, isn't it? So it is plus log x squared to base 2. Then you go to the next one. This a half is the power, isn't it? Yes. So you have log x raised to power half to base 2, isn't it? Then that one is equals to, this 37 is the power, isn't it? So you have Log 2 raised to power 7 to base 2. Then what did we say? You go to the next law of logarithm after removing the coefficient, isn't it? Remember, we had the law that when you have log xy, that is the log x plus log y. When you take the log inside, multiplication changes to addition, meaning we go back. Meaning you must have one term on either side of the equation. Are you see? You must have one term on either side of the equation. So if you factorize out log to base 2, meaning where there is addition goes back to multiplication, isn't it? It is a reverse process, isn't it? So here we have, what do we have here? Here we have x raised to power 16. Then addition goes to multiplication, isn't it? We have x raised to power 2. Then addition again goes back to multiplication, isn't it? X raised to power a half to be equals to log to base 2, 2 raised to power 30. Are you seeing that? You must ensure that both sides of the equation is one term. Are we together? So from here, what do you see? When you take back the log inside, multiplication will go back to addition, multiplication will go back to addition. It is a reverse process, isn't it? So from here, it means you introduce log to base 2 on both sides of the equation. That is what it means. So you can now ignore log to base 2 on both sides of the equation. Are you seeing that? That is why you have to make it one term on either side of the equation so that we are able to ignore, isn't it? So can you now simplify this? When you have same base and the multiplication signs, you add the powers. This is base x, same base. You add the powers, meaning it is 16 plus 2 plus a half. Same base with multiplication sign, we add the powers, lots of indices, isn't it? Then that one is equals to 2 raised to power 37, isn't it? So what is 16 plus 2 plus a half? That is 18 and a half, isn't it? 18 and a half. What is 18 and a half? This is 18 and a half. 18 and a half is 37 over 2, isn't it? See, 18 and a half is 37 over 2. You've now simplified it. So how do you get x? See, you multiply both sides of the equation, lots of indices, by the reciprocal of this, isn't it? 37 over 2 meaning we multiply by both sides of the equation with the power 2 over 37. So the power outside times the power inside, lots of indices, isn't it? So this times this will remain with x, isn't it? Are we together? So x is equals to 37 goes with 37, you remain with the 2 raised to power 2 raised to power 2. 2 raised to power 2 is equals to 4. So you solve for x. X is equals to 4 using all the laws of logarithm. So you can never solve a logarithmic problem if you don't know all the laws of logarithm. Are you getting what I was saying? Good.